There's your thought for the day. By Lou Holtz, former Notre Dame football coach. 2.3 is angle measure in polygons and tessellations. So when you get done with this lesson, you'll be able to determine angle measures in polygons and determine vertex angle measures in regular polygons. Linked to prior knowledge was naming angles. A polygonal region is a polygon together with the portion of the plane that is enclosed by the polygon. So here's a picture of a polygon. And here's a picture of a polygonal region that it includes the space inside the polygon. Next definition is tessellation. A tessellation, or tiling, is an arrangement of polygonal regions that cover an entire plane without gaps and no two polygons overlap. All these pictures up here are tessellations. Now the tiling they're talking about is like this one here with triangles, squares, and hexagons. It uses regular polygons. There's a tiling, the rhombuses. So that's what they're referring to in the notes. But really, all these are tessellations. It's a repeated pattern with no gaps. And you guys will do those at the end of the year. So here we have a square tiling, and then you've got triangles, and then even this one on the third, according to the definition, there are no gaps and no overlaps, so that could be considered a tessellation as well. An angle measure in a triangle. The sum of the measures of an angle of a triangle is what? 180, right. 180 degrees.
Teachers, at this time, please disregard the noise coming from the PA system. They're working on the system at this time, and they're trying to get it all up and running as soon as possible. So please disregard.
Okay, so in this problem, what would the missing angle be in this example? Yes? What'd you say? 81. Yes, it's 81, because you would take 180, the sum of the angles of a triangle, 180 minus 65 minus 34, and you're going to get 81 degrees. So that would be 81. Let's do this problem. Let's number the angles. We'll call this angle 1. This is angle 2. Angle 3. 4. 5. and 6. Right? So let's find the missing angles. Somebody tell me how to find one of the angles here in the picture. We've got these markings showing that these two angles are the same. So let's, yeah, Jacob.
On the 124 degrees,
Yeah.
you can just go to the other side and subtract 180 minus 124.
Okay, yeah, it's a linear pair. They make the angle 3 and 124 make one a straight line, so it would add up to 180. So you could take angle 3 plus 124 equals 180. Solve for angle 3. We get angle 3 equals 56 degrees. We could do the same thing with angle 2. It's the same situation. So we can say angle 2 equals 56 degrees. What else can we do? Luke.
You can subtract 124 from 180 and divide that by 2 to get angle 6 and angle 5.
Right. So if we wrote that out, we could say angle 5 plus angle 6 plus 124 equals 180. So angle 5 plus angle 6 is equal to 56. And since angle 5 and angle 6 are the same, we could say 2 times angle 6 equals 56. Angle 6 equals 28. And if angle 6 equals 28, angle 5 equals 28. All right. So now we've got 5 and 6. They're 28 apiece. What other angle can? How about angle 1 or angle 4? How could we find that? Yes, Mia.
For angle 4, add those two angles, 56 and 53, minus them by 180.
Right. We could do 56 plus 53 plus angle 4 equals 180. So angle 4 equals 71. And we can do the same thing with angle 1 on the other side. We can do 56 plus 90 plus angle 1 equals 180. So that's going to be 146 subtracted from 180. So angle 1 will equal 34 degrees. All right, any questions? Okay, good. I'm going to draw a pentagon. How many triangles can I divide this pentagon into by connecting diagonals or non-consecutive vertices? How many triangles could I split it into? Yeah.
3.
Yes, I could split it into 3 triangles. What would the measure of the angles of 3 triangles be? $180 times what? 3 triangles? Yeah.
Times
Yeah, 180 times 3 or 540. All right. What about this hexagon? How many triangles can I divide it into? Similar manner. Yes?
4.
Right. We can divide it into 4. 1, 2, 3, and 4. 4 triangles. Right? So, using these two as examples, what do you think the sum of the measures of the vertex angles in a polygon with n sides is? What could be an equation for figuring out if I had 10 sides? What would I do to figure out what the total of the angles would be? Yes, Brian.
180x.
Okay, 100. Okay, so we said the angles for this pentagon, is it 5 times 180? There's 3 triangles, right? So there's 180 3 times within that shape. So it would be 3 times 180. What would it be for the hexagon? There's 4 triangles. Yeah, Luke. 4 times 180. Anybody see the pattern now? What do we multiply 180 by? It's not the number of sides. Madeline. The number of triangles, and the number of triangles will always be what compared to the number of sides? Chris? Yes, minus 2. So we could express that as n minus 2 times 180. The number of sides minus 2 times 180. That tells you how many triangles are in the shape. That will give you the total of all the angles in that polygon. When we're talking about the angles, we're talking about the inside angles here. The total of those angles will be n minus 2 times 180. Regular polygons. Polygons in which all of the sides are congruent and all of the angles are congruent. I would mark this regular pentagon with an arc mark in each of the angles. That shows that they're the same. And a tick mark on each side. That shows that they're the same measure. So that's a regular pentagon. Let's find the angle measure of the regular pentagon. So we know, well, how could I do it? Given what we know to do. How could I find the angle measure of one of the angles in a regular pentagon? Jacob?
You have to divide it into triangles.
You don't divide it by the triangles. Not by the triangles. Madeline?
You're gonna put it in the equation 5 minus 2 instead of 3 times 180.
So, okay, so you have to find the total. We've got to do n minus 2 times 180. So we plug in the number of sides. It's 5 minus 2 times 180. So that's going to be 540. Right? What do I do to 540 to figure out one of the angles? What am I going to do to 540? Chris?
Divided by 5.
Yeah, we divided by the number of sides. So we're going to take 540 divided by n. So that's going to be 540 divided by 5, which gives me 108. 108 degrees. if I were to generalize what we just did in terms of n, what would my equation be? For one angle, a vertex angle in a regular polygon. Now remember, it has to be regular. It's not any polygon. It's a polygon where all the angles are the same. What would the equation be? We just did it. What would it be in terms of n? Yes, go ahead.
180 and minus 2 over n.
Yes. So n minus 2, it'd be n minus 2 times 180. Make sure you put the n minus 2 in parentheses, divided by n. Vertex angle of a regular polygon measures 157.5. How many sides does the polygon have? How can we figure out this? It's not asking for the angle measure, it's wanting to know the number of sides. What would I do? Okay, well I do my 157.5 degrees, and I set it equal to the equation we just derived. N minus 2 times 180 divided by n, right? So then we solve for n, so we would multiply the left side by n. 157.5 degrees equals the n on the other side cancels, so it's n minus 2 times 180. Then we distribute 157.5 degrees is equal to 180 n minus 360. So that's going to be, then we subtract 180 n from, we subtract 3, this is I forgot to have my n here. It's 157 n because we multiply both sides by n. So that's 157 n. Then so now we subtract 180 n from each side. It's negative 22.5 n equals negative 360. Solve for n. N equals 16. Number of sides would be 16. All right, any questions on the notes? No questions.